Hi everyone, today's question is from kinematics, motion in a straight line. The question says a particle starts moving rectilinearly, which means it is moving in a straight line at time t equal to 0, such that its velocity v changes with time as per the equation v equal to t square minus 2t in the units meter per second. We have to find the interval of time during which the particle is retarding. Retarding means it is slowing down. Okay. Now this is the given formula for velocity, right? Now in our previous videos already we have learned that if a body is slowing down or if the body is retarding, then the condition is velocity v and acceleration should be in opposite direction. What that means is if velocity is positive, acceleration should be negative, or if velocity is negative, acceleration should be positive. So let us try to find acceleration from this formula. We know acceleration is dv by dt, right? And if you take differentiation of t square, you will get 2t, and differentiation of minus 2t will give you minus 2, right? 2 will come outside, dt by dt is 1. So this is your velocity and this is your acceleration. Now just now I told for retardation, what is the condition? If velocity is positive greater than 0, then acceleration should be negative. Or another possibility is velocity is negative and acceleration is positive. Right, so let's see in which interval this condition is satisfied. So let's ask when is velocity greater than 0? Okay, when is velocity greater than 0? So for velocity to be greater than 0, this should be greater than 0 because this is velocity formula, right? So t square minus 2t should be greater than 0. To t square, if you take it this side, should be greater than 2t. 1t will cancel, so t should be greater than 2. So if t is greater than 2, your velocity will be positive. Acceleration to be negative, because if velocity is positive, acceleration should be negative, right? So for acceleration to be negative, what is the condition from here? 2t minus 2 should be less than 0. So 2t should be less than this, minus 2 will go here 2. So t should be less than 1. So t should be less than 1 and t should be greater than 2. Now is it possible for t to be less than 1 and for t to be greater than 2 together? Is it possible? No, right? You cannot be less than 1 also and more than 2 also. How is it possible? If you are less than 1, you cannot be more than 2. That means these conditions are not possible. Therefore, it is not possible for the body to do retardation in this interval. Which interval? T greater than 2 and t less than 1, there is no retardation. Now, so this is not possible. Let us check this one. So v less than 0. When will be v less than 0? So t square minus 2t should be less than 0. To t square should be 2t will come this side. So 1t will cancel. So t should be less than 2 seconds. And I want a to be, if v is less than 0, a should be greater than 0 for retardation, remember. So 2t minus 2 should be greater than 0. 2t should be greater than 2. So t should be greater than 1. So for t greater than 1, right, greater than 1 but less than 2, in this interval, right, in this interval your velocity is negative and acceleration is positive. So in this interval there will be retardation. Okay, so the right option is option B. Now there is another way to solve this problem without doing any differentiation, and that is by plotting the graph of v versus time. Now students, try to remember this small concept, very useful. Let's say you have a formula y equal to 2x square, okay, and y equal to minus 2x square. Try to plot graph of this. Okay, let's see. So when x is 0, y is also 0, right? So this is the first point. When x is 1, y is how much? 2 into 1 square will be 2. So when x is 1, y is 2. So here is the second point. When x is minus 1, what is y? Put minus 1 here. Minus 1 square is also plus 1. So when x is minus 1, y is again same value 2 only. So your graph will look like this. Okay. Try to see the same graph for this equation. When x is 0, y is minus 0 is 0 only, right? So when x is 0, y is 0. When x is 1, y is how much? Put 1 here, minus 2. So minus 2 means here. And when x is minus 1 square is plus 1. So y is again minus 2. Minus 2. So your graph will look like this, right? So try to remember this. Whenever there is a square, the graph will look like this, parabola. Okay, these are called parabolic graphs. And if the coefficient of x square is positive, if the coefficient of x square is positive, the graph will be open like this. So the concave part will be up. And if the coefficient of x square is negative, the graph will be like this. So convex will be up. Okay, so try to remember this. So now let us try to plot this graph. Remember, in the question we have to start from t equal to 0. So here is your t and here is your v. Right? Now let us find the easy points where v is 0. So where will be v 0? This is a quadratic equation. So t square minus 2t should be 0. So t common, t minus 2 0. So t equal to 0 and t equal to 2. So for t equal to 0, your v will be 0. Also for t equal to 2, your v will be 0, right? So here v is 0, here v is 0. Okay. Now what about t equal to 1? Let us check easily from here. So t equal to 1, if I put, v will be 1 square is 1 minus 2 into 1. So this is minus 1. So this is minus 1. Here is your minus 1. Now because this is a square, we know the graph will be parabola. But the question is, will it be open like this or like this? Well, check the coefficient of t square. Here the coefficient of t square is positive. So the graph will be like this. Okay. Like this. And from here onwards, the graph will just keep going like this. Now, when is a body said to be retarding? When its speed decreases. Okay, speed. And speed, remember, is modulus of velocity. So this should decrease. So let's check in which interval the modulus of this velocity is decreasing. From 0 to 1, the modulus of velocity is going from 0 to 1, remember. Remember, minus 1, if you take modulus is 1. So it went from 0 to 1 meter per second. So it is moving faster, right? 0 to 1 meter per second. But from 1 to 2, if you look carefully, it is going from 1 meter per second to 0 meter per second. From 1 meter per second, if you go to 0 meter per second, means your speed is decreasing. So in this interval, you are retarding. And same thing we got by using calculus also, right? By using differentiation. After 2, what happens? After 2, the speed is increasing, right? It is becoming here 0, then here it will be plus 1, then plus 2. So speed keeps on increasing. So after 2 seconds, it is accelerating. Before 1 second also it is accelerating, because remember, its speed is increasing from 0 to 1 meter per second. Let us try the same question if this was the formula for velocity. Okay. So I'll try to do this graphically. So first I will try to find where are the points where velocity is 0. So for velocity to be 0, minus t square plus 6t minus 8 should be 0. Now this is a quadratic equation, right? And this is minus 8 minus 1, which is product will be 8. This is 6. So it should be 6t should be splitted into 4t plus 2t, right? And then we can take minus t common, so t minus 4, because minus minus will be plus, and here I can take 2 common, so t minus 4, and that will give you t minus 4 minus t plus 2 equal to 0. That means first solution is t equal to 4 seconds, and second solution is t equal to 2 will go this side, minus minus will cancel, t equal to 2 seconds. So these are the 2 points where your velocity will be 0. So here is velocity, here is time. This is your 2 seconds, let's say, and this is your 4 seconds. So now we know the graph will be either like this parabolic or like this, isn't it? How to decide which one it will be? Well, look at the coefficient of t square. It is negative. And what I told you, if the coefficient of your t square, in that time I told coefficient of x square because that time we were drawing graph of y versus x square, isn't it? I think I took -2, right? So if your coefficient is negative, like here, then your graph will be this way. Okay? So the graph will look something like this. And you can expect it to be this way only because when I put t equal to 0, this will be 0, this will be 0, v will be -8. So if I continue this graph like this, you can see this will be -8, isn't it? And when t becomes very large, this square will be very, very large, this number. So if negative number becomes very, very large, this whole thing will become negative. So after 4 seconds, the graph becomes more and more negative. Right? Now check in which interval your speed is decreasing. Speed matlab magnitude of this velocity. Okay, modulus. So the velocity went from -8 to 0. So speed went from 8 to 0. 8 to 0 is decrease. So that means from 0 to 2 seconds. Matlab t less than 2 seconds greater than 0 seconds. What is their retarding? What about at 3 seconds? So from here to here, you can see your speed is increasing. So that is not retardation, right? Then from 3 to 4, again you can see the positive value of this velocity is decreasing. So speed is also decreasing. So from 3 seconds to 4 seconds also there is retardation. Retardation, right? And then from 4 seconds onward, the velocity keeps increasing in negative direction. So it is again acceleration. So in these two interval, there is retardation, right?